हेलो बच्चों। हेलो हेलो हेलो, आवाज़ आ रही है बच्चों? हेलो, आवाज़ आ रही है बच्चों? आर यू ऑल एबल टू हियर? यस नो इन द चैट सेक्शन. Are you all able to hear properly? Yes, no, fast. Chalo, fast. Let's see. Chalo, good. Hi, Half Moon. Rohan, Samiksha, Vimal. Where is other kids? Do Samiksha there, Pavitra there, Lohit Gokul is there. Okay. Where is Kartikeya and others? Come on, join fast, kids. Samiksha ma'am has written, can hear you but see you. Screen coming soon, just 1 minute, 1 minute, 1 minute. Screen coming soon only. So first, we'll be doing a few questions which were left of capacitance, and then we'll be starting the chapter current electricity, okay? Ready everyone? Yes, no, ready everyone? Chalo, let's start. So everybody, I think so, concept video you have gone through the chapter of capacitance. If not, no issues. You all remember the basic formulas, okay? So we'll see how to solve the questions with respect to that. The first question, I'll be giving you 2 minutes. Try it, very simple, very easy. Let's see everybody. Hello. Chalo. Lohit got the first answer A. What about others? What about others? You're all able to see the question? Try, doesn't matter. First, read the question. So once you are reading the question, think which formula matches this question. Okay, which formula I need to apply. Now, if I read the question, students, okay, understand, I'll be doing, if I'm a student, how will I attempt this paper? A system of two charges, okay, nothing given, just two charges are given. Separated by a certain distance, so two charges are there, then certain distance is there. stores electric potential energy. So potential energy is there. I don't know what, how much. If the distance between them is increased. Now, suddenly you have increased the distance. Let's say 2r you have made it. What will happen to the potential energy now? So this should be the diagram in your brain. This should be the diagram in your brain. Clear? Chalo. Some got A, some got B. Okay. Okay. What about others? What about others? What about others? Vimal, Half Moon, Samiksha. Will say. Just 4 seconds. Answer is A only, kids. Answer is A only. Now, why the answer is A? Now, reason is why the answer is A. How many people can say why it is A? Anybody write down in the chat. Let's see. Why you are getting C, Amaya? Tell me. And why, Samiksha, you got B? What is the reason? Harsh, B. Okay. Tell me the reason, kids. Why? What logic did you apply and you got the answer B? So first, whenever we are trying to solve this kind of a problem, what we do? Think with brain, not with heart. Okay? Think with brain, not with your heart. Okay? So first thing is you should know the formula. So they're asking for potential energy. So first, what is the potential energy formula? Potential energy is equal to K Q1 Q2 by R. Correct. Now, case 1 you take it that both Q1 and Q2, either they are both positive or either they are both negative. So we don't know whether the charges are both positive or both negative. So one case we are taking whether both of them are positive or both negative, and the product Q1 Q2 is greater than 0. So this whole value will be positive. Now, if I increase the R, to 2 times, what will happen? K Q1 Q2 by, if I write 2R, if this increases, whole thing goes down. Clear? This is first case. In this case, when both are positive or both are negative, if I increase the distance between them, then the potential energy what? Decreases. Correct? What about the case 2? Case 2 you have U is equal to K Q1 Q2 by R. Now in this case, the product of Q1 and Q2, they are negative. Either one is positive negative or negative positive. Both case. Clear? The product of Q1 Q2 is negative. Now understand, students. Now understand, very very important. Now in this case, if they are negative, if I increase the R dash to 2R, what will happen? Just imagine you have a value. Here you had a value 10. Okay. You increase the radius to 2 times. Earlier it was 10 by 1. So you got 10. Now the moment you increase the distance between them, so it became half. Now here you had 10 minus 10 by 1. Now what you are doing? Again you are increasing the distance. So which one is bigger? Is this one bigger or this one bigger? So here the value increases since it is in negative. Yes or no? Here the value increases since it is in negative. Yes or no? Clear? So we cannot say until unless they haven't mentioned about the charge, we cannot say it will either increase or decrease. Got it, Samiksha ma'am? What about Half Moon? Got it? What about Half Moon? Got it? Come on, fast. Tell me, everybody. Gokul, anybody has any doubt? Sir, I have doubt. Do tell me. Yes, no. Fast in the chat section. Rohan, Vimal, Half Moon, did you get it? Samiksha, yes. What about others? Half Moon, yes. Very simple. See, instead of going and putting your heart and thinking about a drama story and all that, just use the formula. No, U is equal to K Q1 Q2 by R. Sir, I don't know about whether they're positive or negative, so I can come up with two cases. One case the product is positive, one case the product is negative. So in the case the product is positive, this is a positive quantity. If I increase the denominator, the whole value will decrease. In the second case, the product is what? Negative. Sir, if I increase the denominator in this case, the negative value magnitude wise it will decrease. But since negativity is decreasing, so what? It will be what is increasing. Done. Clear? Nobody has doubt. Nobody has doubt. Yes, no, yes, no. Chalo, chalo. Good. Can we move on to the next question, kids? Chalo, very simple, very easy question to you all. Think about it. Think about it. 2 minutes timer I'm giving you all. Think about it. Chalo. Here we need to remember one formula. What is that formula? Electric field is equal to what? dV by dr. dV by dr. Do everybody remember? Potential gradient. Electric field is what? Potential gradient. Potential gradient. Now you think about it. So dV by dr means what it gives. Or in case of this one, it can be dV by dx. Because the distance, this is R is represents distance. So in case here they have represented with x, so dV by dx. So when I talk about dV by dx, it basically shows what? dV by dx is nothing but slope of Vx graph, slope of voltage and distance graph. So more slope, I won't say it. So what you can see, the slope here is constant, slope here is constant. So what I can say, EA and EC, they both are same value. EA and EC were same, EA and EC were same, only one option. Then I don't have to think about positive, negative. A negative potential gradient, correct? In the direction wise, if you see, one increases, the other decreases. Now they have asked for the magnitude, so mod value they're asking. So negative we are not considering a map. Clear? Chalo, D option. Everybody got it? Half Moon, did you get it? Rohan got D. Samiksha. Simple, no, just E electric field is equal to what? The potential gradient, that is dV by dx, that is nothing but the slope of the graph. So if you see the first slope EA and EC, they are same. Slope is constant. EB is equal to ED. But sir, EB is equal to ED. How EB is equal to ED, ma'am? How EB is equal to ED? Tell me. See, even if you consider how EB and ED can be same, tell me. See, the slope for this one and the slope for this one, do you think it is same? Yes, chapter formulas you should go through definitely. No issues. What you do, it will be double benefit once you are doing the questions with me. So this is like 5 questions or 6 questions we'll be discussing, which is left. After that, we'll be starting a new chapter. So don't worry. So next chapter onwards, I'll tell to all the students. So you'll be known that which chapters we are doing. Okay, chalo. So very simple formula. Just we need to know this formula. How you are getting Samiksha ma'am EB equal to ED? Can you explain? The potential slope is different for both of them. No. How did you get the same slope, Samiksha ma'am? Do explain it. Don't worry. After the session ends, okay, be there. I'll explain this question once again. Okay, about the slope part. Chalo. Anybody else has any doubt? Anybody else has any doubt? Which CHP? What does CHP stands for? Full mnemonics Rohan is using, huh? Current. We are using the word current. No need to be sorry, ma'am. Again, that is wrong. Question asking is your right, and you should never be sorry for that. Chalo, let's see the next question. A very simple, easy question. Do not get confused. Very simple, very easy question. Okay. Next chapter, current. Next chapter, after 3 questions max more, we are going for the chapter current. Current electricity. Very simple, very easy chapter, starting from the concepts, and in between I'll put up the, what do you say, questions also. Next chapter, current electricity, Rohan sir. Chalo. This one, everybody, come on, we have already done this question. We have already done this question. Still, I gave it. Try. I think so. We have already done, and a lot of people they gave the answer also. Let's see you remembered. Let's see you remembered. Very simple question. Very simple concept also. Do not worry, half moon. Okay. So whatever you are going through, just try analyze the question. Okay. What it can be. So you'll be able to understand. Okay, the questions are simple. If I had known the formula, I would have got directly. Okay. So the moment that feeling comes, it will make the things more easier. Repeated question, ma'am, correct. Just checking whether you all remembered or not. Vimal A. Where is Karthike today? What about others? Rohan A. Fast, 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 kids. Gokul A. Chalo. So everybody is getting A. Now let's see how are we getting A. Correct. Let's see. So particle of mass M, okay, charge Q, rest in a uniform electric field. It is a uniform electric field is there, and the charge is taking a nap. Okay, charge is here sitting relaxed, no worries about life, taking a short nap. Okay, and then suddenly it is released. So you remember one thing: whenever a particle is released in a electric field, what happens? Force gets applied. And what is that formula? Force is equal to what? F is equal to QE. F is equal to QE. So this is the force that is acting on the particle. Now energy, we know work done is equal to energy, correct? Work energy theorem, work done equal to change in kinetic energy. So, and it moves how much distance? Y distance. So how will we find work done? Initially it was rest, so initial energy, kinetic energy is what? 0, and finally kinetic energy will be there, and that is equal to, how do you find work done formula? What is work done formula? Force into displacement, correct? Force into displacement. So force into displacement is equal to kinetic energy final, because initial is 0. So force is what? QE, and displacement is y, that is equal to KE. Was it very difficult? Was it very difficult, students? Yes, no in the chat section. Very difficult, very easy? Do tell me. Tell me fast. Very difficult, very easy? Clear, everybody? Chalo, anybody any doubt? Anybody any doubt? Chalo, anybody any doubt? Sound is coming off outside door. Yeah, this place, it is not a studio room, it's just a normal room, so a bit of outside noise is there. Okay, chalo. Everybody, let's try this question. Everybody, let's try this question. A option, Bangalore or Bangalore. Right now I'm in Bangalore. Very good. Option A. What about others? Chalo, chalo, let's see. We'll tell. Let's see. Just wait a bit. Almost there. Let's see. Chalo, A option. Amaya, what option first? Tell me, then I'll tell the other option. Chalo, chalo, bachcho, fast, fast. What about others? No options from Pavitra. Others. What will be the answer? Think right or wrong doesn't matter. Think your logic will improve. Very, very important to improve the logic. The way you see in exam, you won't get the exact same question. You'll get something similar to it. So the moment you start thinking, your thinking will advance. Okay, the way you are approaching the problem, okay, the way you're breaking it down. So the moment you see that sir is breaking it down this way, you'll understand, okay, here I did the mistake, I should have done like this. So you need to understand. So do try. Come on, fast, fast, fast. I'll just wait for more 30 seconds. I'll tell the answer. So everybody is getting A. Tell me the concept how you are getting A. Tell me the concept. Anybody? Sir, I just added because parallel and capacitor is same as series and resistor, and then divided. Sir has own college, and then divided individual charges. I don't know if this method is correct. Okay, okay, good. Let's see. Good try. What about others? What you have done? Which way you got the answer? Do tell me. See, more than me, your what is your understanding and thinking right now is important. So come on, tell me fast which way you are getting the answer, which way you are thinking. So first, everybody, see, what happens is, let's understand a simple story. What is that simple story? If two good friends are there, what happens? Two good friends are there. One, they both went to work. So what happened? He earned 100 bucks. He earned 50 bucks only. Okay. So when they came back home, since they are very good friends, so that nobody feels bad about each other, what they did, they all put both of their money in one part, and what they did, they divided by two. Now he has 75 bucks, he has 75 bucks. Okay. So what is this method called? What is this method called? What is it called? Common potential. What is it called? common potential. Why it will happen? See, capacitor you have taken, capacitance C, charged Q is connected in parallel with another uncharged capacitor of 2C. So the moment you connect it, okay, so charges will flow till the time both have same potential. So you can understand with a jug example. Take a big jug, take another jug. Here it has till this much water. Here it has till this much water. The moment you connect it, what will happen? Water will flow in such a way so that they both have same level. They both have now same level. Correct? Yes or no, kids? Clear? So same thing will apply the common potential. Now how do we find this common potential? Correct? How do we find this common potential? So the common potential, simple formula, VC, common potential is equal to on the total charge by total capacitance. Total charge by total capacitance. What is my total charge? The first one has charge Q, the other one has 0. And total capacitance 1C and the other 2C. So how much you will get? Q by 3C. Clear? Clear till here? Yes, no, kids. Got the concept of common potential? The moment that they will say that two capacitors you are joining or two charge pairs you are joining, charges will transfer till they reach common potential. Charges will transfer till they reach common potential. Clear, everyone? Yes, no in the chat section. Till here everybody got it? Yes, no? Fast tell me. Okay, very good. Now let's see. So always remember, two best buddies, they'll always share, okay, and they'll have equal amount. Now let's see. After that, the final charges they're asking on the both one. So what will be the final charges? On the first one will be charge is equal to what? Q is equal to CV. So capacitance value we can't change, but the new common potential they have. So C into Q by 3C. Okay. So CC gone, so Q by 3. And what about the second one? Again same thing, 2C capacitance was there into, but notice a common potential. So 2Q by 3. Clear? Anybody doubt? So everybody got the answer correct? Yes, no, got it? Understood the logic, everybody? Understood the logic, everyone? Anybody has any doubt in this question? Come on, fast. Anybody has doubt in this question? Do tell me. Anybody has doubt? No, very good, kids, good. Chalo. We'll see one more question. Let's see this question, okay? Let's see this question. Let me just, can I take a screenshot? So that it becomes easier for you all to see the question. Chalo. Try it, everybody, fast. Try it, everybody. Let's see. Hi, Keshav. Got late, bro. Now, very good, Samiksha ma'am. See, in generally, when we are solving a physics problem, first thing you need to understand is related with which formula or what thing is getting applied here, what they're talking about. Here in the previous question, the main thing that was the focus is when two bodies are connected, what will happen? Charge will flow. Till how long they'll flow? Till they reach common potential. So this was the line that you needed to pick up. Okay, so every physics problem, they'll tell a story. Okay, the moment you're able to read that story, done. Clear? Samiksha ma'am will say, now I'm more confused, sir. Got it, ma'am? So the basic approach is understanding the problem. If you understand the problem, okay, you will get it. Try this question, everybody. I'll tell in details what you say this one. Don't worry. More than that. And see, first of all, one more thing to all the students. How good or bad the question is, the question won't come out of the page, okay, and scare you. What happens the moment we see question, we feel scared. The moment we feel scared, two or three logics which might be correct, we are so scared we don't apply only. So they are only gone case. If you're going to fight a war and you are beforehand, you know that you might not win, you're thinking that you'll never win. So first, that attitude, problem only, no, what will happen? It won't come and curse me. So try with a genuine attitude. You'll start developing understanding. You'll start breaking the problem. Okay. So one good strategy which British people gave to us, apart they didn't give much good, but one good thing they gave, divide and rule this part. So what you can do, divide a big question into small problems. In reality also, when we come across a big problem, what we do, divide into smaller sets of problem and then take one by one. Done. So everybody is getting 150, 150, 150. Whoa, what about others? 150. Oh my God, you got first correct, Lohit. Half moon, 100 by 3, 100 by 3. Nishat, 150. Pavitra ma'am, B, 50. Okay, what about others? Anybody else wants to try? Samiksha ma'am, A, what about other? Chalo, fast. Never hesitate to try, okay? So the diagram tricked us. Yes, see, one by one, step by step, no need to be in a hurry. First, what I can see, I can just break these two. I can just make these two go over. Correct. Forget about this 50 and all that. Just these two. What are they? In series are. Correct. In series, what happens? Acts like parallel. So first we can make a simple diagram. Okay. So now what will happen? This 50 here. This one became 50. And this one again became 50. Okay. This one is going like this one is coming like this, and this one here. Clear? This one here 50. Now what you see, which one is parallel? If I pass the current from here, like this way and this way, okay, so what will happen? Are these two in parallel? Which other is in parallel? Now I think so everybody is getting it. Now tell me, next step will be what? You tell me. I first did the first step. My target was to get C2 and C3 done. Okay. What I can do, I'll show you one more way. Let's see. So I'll just remove this, everybody. First, I'll try to draw the diagram more proper. So if you see, this is my C4 here. Okay. And that C4, I have removed these two C2 and C3. I have clubbed and I have made this is C2, C3. And with C2, 3, there is one C1 in parallel. So everybody is getting this one, and from here it is getting connected to AB. Now these two are in parallel, 50, 50. What I can do, parallel means I can just add it. Now what I'll get? 1, what I'll get? 50, like this A, and here 100. Is this correct or wrong? So what I'll get the answer? 1 by 50. These two are in series. 1 by 100. So what I'll get? 100 by 3. Yes, no kids. Yes, no kids. Everybody get it? Got it? Let me have some water. Everybody got it? Anybody has doubt? Do tell me. I'll go a bit more slow and explain. Got it? Anybody doubt? Come on, people with the doubt. Do raise your hands, Miso. Hi, Royal Groups. How do it come parallel? Okay. Which one, bro? Parallel? Yeah, which one parallel you are having doubt? See, forget about first these two. They're in series. Yes or no? See, it is a capacitor, ma'am. In series, what happens? The capacitor formulas are opposite. Clear? The capacitor formulas are opposite. Clear? So these two, first they are in series. Clear? So remove these two. So what you will get? 150 here. Okay. This got into 1. Okay. And with this we have a C4 here. Now see how the connection is going. Here the connection is very, very important. The connection is very, very important. Okay. Clear? If the connection would have been here, it would have been a different story, but it is here. Okay. So now this is C4, this is C23, and this is C1. I think so. This one, everybody knows. Till here, everybody got it. Correct? Now what do you do? Bring A one side, B one side. So let's say from A part, take a different color. One part is going to the C23. From A, one is going to C23. Correct? And from that A part, one is going to C1. Clear? Let's say it is going to C1. This is for C23. This is for C1. Now from B part, one is going to C4. Okay. And from C23, one is going C23, this part, it is getting connected with the C4 other part. Just put it with a different color. Correct. So from C23, one is going to the C4 of this part, and from B part, make it red, it will be easier. This part is red. Clear? So this is your C4. Now C1, one is connected with A, the other part is connected to which one? The other part is connected to C23. So from C23, one part is coming and making it like this. Clear? Making it like this. So now can you tell me yes, no, Royal Group? Are you able to see which one is parallel now? Yes, no, yes, no. Are you able to see now? Do tell fast, bro. Did you get it now? See, very easy. In order to understand whether they are in series or parallel, just take a color diagram, may draw it, you'll get it. From which one is corrected, done. So correct option is 100 by 34 written, 100 by 3. Clear? Got it, Royal Group? Yes, no, fast. Chalo. If you didn't get, do tell me, or after the class, do tell me, okay? I'll again explain. Everybody else got it? How we got the plotting and everything? One by one, take one color and you will get it. Yes, no in the chat section fast. Chalo everybody, good. Now let's see the last question for this one, then we'll go for current. Let's see the last question. It's good, you got it. So last question, very simple, very easy question. Let's see. Fast, kids. So everybody will take a 10-minute break after this and we'll start with current electricity chapter. 0, the first answer came out 0, no option for 0. What is the formula here we have to use? I'll tell you the formula. See, electric field we have to find. What is the relation between electric field and potential? E is equal to delta V by dV by dr. Electric field is what? dV by dr. Clear? That's it. Minus dV by dr. Good. Done. So change in potential is there, no, bro? Change in dV is there? No. If this is my final minus initial, delta V by R is only 1. Just convert it into meter. Okay. Done. So what I got? 40 by 2 into 10 square. Correct. So what? 20,000 V per M. Was it that difficult, Lohit sir? You gave 0 directly first time, huh? Chalo, everybody got it? Yes, no, everybody got it? Okay, one more thing, students, one more good news for you all. From those who are writing CET, first PU part from 11th portion, 30% have been reduced. I'll make a detailed video about that also, don't worry. 30% have been reduced from the 11th portions. What has been reduced? I'll tell you, okay? So don't worry, it's a good news. So 30% have been reduced. Second PU, all thing is there, 100%. So this is the most important, okay? Chalo. Clear, everybody. Chalo, everybody getting good. So it is right now 9:40. 9:50 can we expect everybody to be there? 9:50 max, 9:55. Don't be late. Okay? We'll start with the chapter current electricity. We'll start with the chapter current electricity. Clear? So we'll start with the chapter current electricity, okay? No updates as of now. Will be anything. If it comes, I'll do update it. Today KE website has things, I think so it's given. So COMEDK, if they update, as of now they haven't given any update. So we'll inform you all, okay? Don't worry. Chalo. Good day, everyone. I got a bit late. You all are on time. Okay. Let's start it. Everybody. Ready. Yes. Chalo. Okay, Nishat ma'am. Okay, what about others? Join fast. Let's start. Chalo. So we will start now. Everybody ready? Lohit sir came. Okay, chalo. So we are starting the chapter current electricity, students. Very simple, very easy chapter. Okay. Just give me 1 second. 1 second. Just. Videos are there. I'll send you the link. So don't worry. We have done mat and det. Okay, fully. So don't worry. You can start from here. Okay. We started about that. What do you say? Matrices part, and from there the live sessions are there. Pick it up from there. Okay, and from there just keep doing whatever doubt you are getting. We'll put up a doubt class. There you can would just rectify it, whatever your doubts. Okay. These three are there, I think so. Shalom. So let's see, everybody. Let's see. Let's start. Already we have started. Let's see. So it's now what about the current? Let's first go with the basic properties and everything. What is there in the current part? Now weightage wise for those who are doing CT and COMEDK, weightage wise also let me tell you how much it is important. Okay. Just be there 1 second. Physics analysis. Yeah. This is maths analysis, physics 21. Now everybody, are you able to see the screen? Yes, no, yes, no. Sir, I refer to the videos in the app. Is that okay? Sir, if I refer, yeah, that will be okay. Anything extra? Everybody who are new to the channel, who are old, what do you need to do? The concept which we are teaching, concept video, along with that PYQ, plus NCERT solved example. Try, but don't solve fully. Try to solve like with a trick and get the answer. Okay? And exemplar solved example. Clear? This much, at least target twice to thrice revision. If that is done, it's done. Clear, everyone? Now, if you see the chapter current electricity for CET students, it's what 6866664. So minimum 4, maximum it can go to 8. What is not clear, ma'am? Vidya, ma'am, what is not clear? So what you can see, the weightage, minimum 4, maximum 8, average if you see it is 6. So current electricity is like a high voltage chapter, a very high weightage, okay? So 6 marks means, yeah, I'll be teaching the basics now, okay? Basically what we'll be doing is, whatever the important formulas that you will require for solving each and every question of CET, we'll be giving you that. And we'll be explaining you how to use that formula, that's it. Okay, we won't go total into the too detailed about that, but yeah, that much which is required to solve each and every question, we'll go about that. Clear? So talking about the analysis, this is a very high weighted chapter. So if you're doing first 4 chapter, kids, you are able to capture minimums, 6 here, 4 here, and again 3 to 5 here. So 6, 4, 10, 15 marks here, and till moving charge and magnetism 20 marks. So first 4 of your 12 topics, they are very high weightage. 20 to 25 they can give you. Okay, 20 to 25 they'll give you. Will this be enough? What will be that concept? The concept videos will be enough. For CET, we have taken any question which is there, which came from 2014 to 2021. You will be able to solve. So if you are able to solve what came, and we have not left anything of NCERT or anything here and there, and something extra also we have put up. So I think so that should be more than enough for you for the exam. Okay. Now what about COMEDK? COMEDK also we have done the analysis. I need to check. Just give me 1 minute, 1 minute, 1 minute. I'll check the PDF. 1 minute. Let me check the PDF where I've kept. That will be enough for KCET 2022. Don't worry. So whatever is needed, we have given more than enough in that. So it should be more than sufficient for you to score a good marks in that. Just give me a bit of time, students. Let's see where I've kept the analysis PDF. COMEDK also current is very important, don't worry. But how much exact value, let me tell you. Yeah. Both is okay, no issues. Almost similar is there. App videos also in here. So you can refer both. Okay. Now in YouTube, like not all the questions we have done in app, more questions are there in the PYQ section. So don't worry. Now, see here everybody, in the COMEDK analysis part, if you see, electric charge is also important, 3 marks, potential 2 to 3, current 5 to 3 or 3 to 6. So COMEDK, as I earlier also told, I have said, what do you say? Told is wrong English. As I've earlier said, in COMEDK the fluctuations are a bit more. Okay, so minimum 3, maximum it can go to 6 in current part. Clear? So again, a very valuable chapter, current electricity for COMEDK also and for KCT. Clear? Chalo. One second, students. So many files are there. Yeah. Chalo, let's see. Weightage and all, I have done the discussion. I'll just send you the video. Okay. I've done the weightage discussion also, and I've done KCT versus COMEDK also. Don't worry. I've done physics analysis, maths analysis. You'll get the link. Okay. So these are the links. I'm just pasting it. This is for your weightage part. In app, we have a bit of paid course, ma'am. Not fully free. We have kept the cost as minimum as possible from our end. We don't have much students as of now. But yeah, we have done the physics analysis also. I'm sending the video. Because CET COMEDK, very rarely people study first and then second they don't take much of paid course. So let's see everybody. Okay, what would we have here in this part? Current electricity. Now let's see what is there in the current electricity part. First, the basic, what is current? So we all know rate of flow of electric charge. How fast a charge is running, that is current. Clear? So what is current? I is equal to Q by T. So the best way to, watch this video is take a pen and a paper and start writing and make your notes also. Yeah, app is available in the website also. Web app is available. Okay. Chalo. Now, first is I is equal to Q by T, current is equal to charge by time. Now, if I want to find at particular instance, then what I'll do? I'll take very small charge by very small time. So if very minute charge is going in a very minute time, I'll get what? Instantaneous at that moment. What is the current? What about average? Total net charge by net time done. Net charge by net time taken. That's it. Very simple. Clear everyone? So first the current formula we should know. Very simple questions keeps coming from here also. Okay. Next, Q is equal to NE. We'll see a lot of questions from this also. Quantization of charge. Q is equal to NE. Charge is equal to what? Always it comes in the form of integral multiples of electrons. You can't have half electron somewhere. You'll have 1 electron, 2 electron, 3 electrons like that. Okay. So if I put in place of Q, that is NE, what I'll get current formula I is equal to NE by T. Clear? Now next, earlier people, they were very much obsessed with positivity. So what they thought, uh, for COMEDK as of now, we haven't got any notice. Okay, so the moment we'll get, we are looking into the website constantly. The moment any notice pops up, you will be able to know. As of now, KEA has given the circular about 30% reduction in, what is say, first PU topics. So about this one, we don't know. So don't worry, we'll get to know. Chalo, let's see. Next, what we have? Next we have is, conventionally the direction of motion of positive charge was considered to be current. Means if a positive charge is moving, that's it, then the current direction is this. But actually we know what? Electrons movement constitutes current. So electron direction should have been the current direction, but it is opposite, because people earlier, they were very, what do you say, biased. Okay, they're more into like, what do you say, whatever the positive things are, that only should be mid spatial. Okay, chalo. SI unit of current, ampere we know. So 1 ampere is equal to what? SI unit of charge is what? Coulomb. And SI unit of time is what? Second. So 1 coulomb, if 1 coulomb charge is flowing through any body, maybe a conductor only, at a rate of 1 second or per second, that is 1 ampere current. Clear everyone? Till here clear? Do write it down fast, everybody. Do write it down. So here only, what do you say, your notes will be done. You don't have to worry for here and there or run or ask for anything. Okay, fast everybody. I'll give 2 minutes. The live will go till we finish. Next page. A very simple question, everybody. Try it out. What is the question telling? What is the question telling? Charge is given. Okay. Time is from 1 second to 2 seconds. What is the current? You have to find the current. So they are telling, find the current that has been there from 1 second to 2 second. Let's see. Done. What is the answer, Soham? What should be the answer? Somebody said 4, somebody said 6. Let's see, is it 4, is it 6? Chalo, let's see directly. What we will do, put the value, delta q by delta t, delta q by delta t. So if I directly show it, what will be the answer? Is it correct? Why am I wrong? What do you say, students? What you have done? Q final, see, charge final is equal to what? At t equal to 2. So 4, when I put it t equal to 2, 4 plus 1, how much? 9. What about charge initial? So put 1, sir. 1 plus 2 plus 1, how much? 4. So delta Q net charge, 9 minus 4. Delta T, 2 minus 1. How do you all got 4 and 6? Students, come on, explain me. Half Moon, Rohan, Vidya. Come on, tell me. So dq by dt. Okay. See, if dq by dt if you are using, no, they won't give you the delta t. They won't give you like that, okay? They have given delta t by time, t final and t initial, okay? So they won't give you like that. They'll say it depends on time. They'll give you q is equal to just like this, okay? And then they'll give you. Now see, instantaneous means it doesn't matter that it has to be only 1 second. It can be 1 nanosecond also, 1 more microsecond also. So if it is 2 to 1 second, it doesn't mean that it is that instant. It can be very small or instant of time also, no? Clear? So physics is very broad. We don't know like the time span which we are seeing is we can say instant or not. Clear? So for somebody, let's say if you are doing an experiment for something, 1 second can be a very big value. Okay. Let's say there are few bacteria, let's say a hypothetical situation, which survives only for 1 nanosecond. Let's say. So for them, this time is like, whoa, it's like a century or something. Correct? So until unless they say, you can't take it before that. Okay? Clear everyone? Chalo, let's see the next one. Next is, what is current density? Anything density is what? By divided by area. If I ask what is pressure density? Pressure by area. Clear? Everybody got it? So SI unit is what? For current, ampere, for area, meter square. Done. Vector quantity. Clear? Now electric current in a conductor. Conductor is what material we all know, which allows the current to pass. Now charge carriers in metals, it is free electrons. Electrolytes, it is ions. Next is Ohm's law. What is Ohm's law says? Very simple, very easy. Current is directly proportional to the potential difference provided physical conditions remain same. So I directly proportional to V or V proportional to I and V is equal to IR. Very simple, very easy. What points are important here? This point and this part. This point and this part. Clear everyone? Write down fast. A fast note, nothing much is there in this page. Next, everybody, let's see next part. Now, anything which follow Ohm's law, directly we can say it's a ohmic. Which doesn't follow Ohm's law, non-ohmic. Simple, nothing is like that. Now, resistance. V is equal to IR. So, R is equal to what? Potential by current. Now, what is the definition? Why, when is we say the resistor of a resistance, or the resistance of a resistor 1 ohm, when the voltage applied is 1V and the current passing through is 1 ampere. That's it, done. We know the dimension also. Now, this is directly proportional to what? Length of the conductor. Inversely proportional to area. This is all we have studied in class 10th. R is directly proportional to length. More bigger wire, more resistance. R is inversely proportional to the area. So if we have thin wire, we have what? More resistance. More resistance. If you have thick wire, fat wire, okay. So we have less resistance. So if you see AC wires, they are more thick. So more current can pass through them. Very simple, very easy, nothing more than that. Clear? So from there we get the formula R is equal to rho L by A. Very simple. And this resistivity, it depends on nature of material, what you are taking, and temperature. This is important because resistance and all we all remember. Resistivity, what they do? They'll change the substance, rho will change. Okay. And if you change the temperature, also rho will change. So this you should know. Write down fast. Done, everyone. Come on, fast, fast, fast. We have to go fast. Very simple, very easy chapter. We don't have to do a PhD in this. Okay, neither we are preparing for JE. So we don't have to go too in depth. Okay. Concepts is good, but right now we have very less time to go that much in depth because we have to revise. Okay. And the questions which are coming is like you'll be able to see from the top surface because you just have 45 seconds or max 60 seconds to solve one problem. In that, they can't give you a lot of difficult questions. Now, rho is equal to AR by L. We all know that is simple. Next is conductivity. What is conductivity, student? It is reciprocal of resistivity. Sigma is what? 1 by rho. Simple. Unit Siemens per meter. Conductance reciprocal of resistance G. We call it as Mho or Siemens. Clear? Very simple. Nothing more, nothing less, to the point what is required. That's it. Clear? Make your notes so that you can revise multiple times. What makes you a topper is the revision part. Because in exam, the person who will be getting more marks is the one person who is able to recollect more and more faster. The moment you see, oh, this, what is it? This is the formula I need to. That comes with practice again and again, again and again. Okay. So a lot of people, what happened is, earlier they were preparing for JEE and suddenly they have to change for COMEDK or KCET. So what happens? The idea, the way we prepare for JEE, we go too in depth because we need per question we have 4 minutes. So we have to go say, what do you say? The concepts from 3-4 chapters are mixed to get one good JEE question. So in that we need to, but here we don't. So you have to just go, okay, this is the thing, this is there, these are the formulas, this is the way to solve. That's it. Okay. Chalo. Once done, do tell me. Once done, do tell me. And everybody be fast. Just like in school days when, what do you say? Ma'am used to come for the board and she used to write and then done. Erased. So we used to write very fast. Come on, fast. Done, everyone? Good, good, good. Chalo. Now, this is the important part. From here, a lot of questions they keep coming. From CET also and COMEDK also. What they do? R is equal to rho L by A. Now, keeping volume constant, you are increasing this. What will be the change in R? So, like this kind of question will keep coming. Okay, this kind of questions are there more in exam. So this is important part. Okay, what is important part? They'll say volume constant. So V is equal to what? Area into length. So R is equal to rho L by A, multiply with length top and bottom. So now here your volume is constant, rho is constant. So what has happened? The resistance directly proportional to L square. If you make the length double, R will be 4 times. Clear? So directly you can write the answer. So these things should be there. Okay. Clear, everyone? If they make area constant, now they're changing the volume. So how much time they change the volume? That much times it will be. Clear? So like that way we can do. Or again they made volume constant. Now they change the radius. They made the radius double. So it is area square. So done, R power 4. Clear? So this way you need to think and you need to solve. You don't see, you can solve these all questions by taking a lot of time, like let's say 3 minutes, 4 minutes. Yes, definitely you can solve. Not very difficult. But if you're taking 4 minutes, understand you have taken the time for the next 3 questions. The next 3 questions you have killed that time. And the moment you try to make up that, you'll start doing in a fast manner, and the what is the chances are there, you'll start committing error. Okay, so everybody, after your bio exam, I think so bio exam is there on 29th, correct? 29th or 30th? When is the bio exam for CBSE kids? Is it 29th or 30th? So I don't know, maybe, but on the 1st of June, we have launched the, okay, I'll again explain. We have launched the test series. Okay, very simple, very easy. What is it? Start practicing the test series also. Very, very, very important. 38th. Okay. See here, everybody. We know R is equal to resistance equal to rho L by A. Everybody knows. Now suddenly they gave a clause. What is that clause? Sir, volume equal to constant. Sir, volume constant. Now like volume constant. What are we gonna do? Sir, we'll change the equation. Now what I'll do? I'll multiply first equation L top bottom. So what I'll get? Rho L square by V. Now they said volume is constant, rho is already constant. So R is directly proportional to what? L square. So if I double the length, resistance will be what? 4 times. Yes or no? Resistance will be what? 4 times. No doubt in that. Yes, no, kids. Yes, no, kids. Do tell me this part first. Any doubt in this? Yes, no, yes, no. Fast, fast, fast. Do you have a doubt in this, students? If you have a doubt, I'll again explain. Come on, tell me fast. Chat section is loading slowly. Half moon, Shoham. Any doubt, bro? Check it, check it, check it. Yes, sir, no doubt. What about Shoham? Doubt, no doubt. Vidya, no doubt. Good, good, good. Shoham, no doubt. Rohan, any doubt? Chalo, no doubt. Chalo. So this part everybody got it. What about the second part? Let's see. If they're changing the area. So R is equal to what? Rho L by A. Now I need to keep the area. So let's keep the area. Multiply top and bottom with A. So what I'll get? Rho L into A is what? V by A square. Now see, these two are constant. So R is inversely proportional to 1 by A square. So R is inversely proportional to area means what? Pi R square. So R power 4. So if I am making the radius double, R will change to how many times? R will change to how many times? Resistance? Come on, people, tell me an answer. If I'm making the radius double, it will be what? 1 by 2 power 4 times. 1 by 2 power 4 times. Very simple, very easy. So this is the way you need to approach these kinds of problems. Clear everyone? Clear everyone? Yes, no in the chat section fast. Got it, everybody? Got it, everyone? Good, good, good. So write down, everybody. Write down fast. Crystal clear. Very good, crystal clear if it is. चलो अच्छी बात है बच्चों. Hi bro, Kartike, where were you? And where is the other friend, Lucky? It's been ages, I haven't seen you guys. Where were you? There is a good news, huh? CT 30% reduction is there. COMEDK will say something or the other. I don't know as of now. We'll get to know. Chalo. We'll go for the next page, everybody. Let's see the next page. Chalo. In this page, student, we'll see how temperature dependence of resistance. Means with the help of temperature, how much change will come in the resistance. Okay. So what you can see from this graph, if I'm increasing temperature, this resistance value is increasing. That is simple. That is because see here it is all things are mixed. So ज़्यादा फायदा कुछ नहीं है, ठीक है? तो पढ़ना तो पड़ता ही है. वो क्वेश्चन इधर उधर मिक्स सीटी में रहती हैं, ठीक है? But okay, it's still what you say. 12 topics are more important, ठीक है? चलो. So RT, resistance at any temperature T is equal to resistance at initial temperature 0, bracket 1 plus alpha, they'll give you, that is temperature coefficient, into change in time T2 minus T1. This is the formula. By using this formula, I can find the temperature at any time T. Clear? Which is starting from R0, okay, to any other time T. Clear, everyone? Next will come the concept of drift velocity. We'll come to the concept of drift velocity. Now, have you noticed one thing, students, that if you put your phone charger or something which has an indicator red color light, even though you have taken out the charger from the socket, it still glows. It still glows for 1 second or 2 seconds, sometimes 3 seconds. Does anybody know what is the reason for that? One second, student, 1 second. Chalo, everybody. Hi, Nitish. So, drift velocity. Anybody can tell me the answer for that one? Which question I asked? Who can tell the answer? Think about it. Okay, don't be in a hurry. Think about it. It's a good question, and it's related to drift velocity. Okay. Now let's see. We'll again come back to that. What is drift velocity? Velocity with which electrons are drifted towards the positive end of the electric field. Now let's say this is the positive end. So what is happening? Electrons are not moving. One is coming and kicking the other is kicking the other is kicking the other. Clear? So this drift is there. They are being, what is it, attracted towards the positive part, one after the other. So here only the answer is, even if you have switched off, the electron is still going. It is, what do you say, just like, what do you say, let's say you are standing in a line. Okay, so you pushed the next person. So what will happen? Though you just push the next person, the next will push the next, because you're all in a line. So the next will push the next. It will keep going on till the last person fell down. Okay, so that is the thing. So in a charger also same thing happens. Okay, though we have disconnected from the socket, the electrons are being what? And sometimes what happens, this electrons are still getting drifted. So the moment we connect in the, what you say with the phone, for 1 second or nanosecond, it just shows, okay, it's charged, like a bulb glows, okay, a light comes on the screen, and then it goes off. Clear? So because of the drift velocity, because whatever the electrons are here, they're already drifted. So now until unless they reach the end, they won't stop. Clear? Though we have removed the positive here, but they're drifted. No, they got attracted. So they have, what do you say, kicked the next electron. They have kicked the next electron. So they have kicked the next electron. So like that way, the kicking is still going on. Chalo. So electron has a thermal energy due to its own kinetic, and the drift due to the electric field applied. Whenever you apply electric field, what will happen? They'll be attracted towards the field and they'll move towards it. Clear? Clear? Yes and no? समझ आया बच्चों? Come on, fast. Very simple. Don't go more deep into that also. As of now, don't go. Again, once we are solving the questions, we'll be able to understand also how the problems are getting solved. Got it, everybody? Yes, no, yes, no, no. Everybody is too silent. Gokul, yes. What about others? Nobody is writing. If you didn't get, do tell me. I'll again explain. No issues. Drift velocity is nothing much bigger concept. Very simple. That electron, they don't see this electron, which is at the end, it doesn't come up. Okay, what it does, it pushes the next one. So the next one pushes the next one. Hi Lucky, where were you? This one pushes the next one, and this one pushes the next one. So this is called drifting. Clear? Chalo. Next, this part is very important. This part is very important for your CT and COMEDK point of view, because questions will be asked from this point. Okay, questions will be asked from this point. देखो ड्रिफ्ट वेलोसिटी में जस्ट एक सिंपल सा आप लोग एग्जांपल समझ लो व्हाट इज देयर इन ड्रिफ्ट वेलोसिटी you have a positive plate here, electrons are sitting normally, let's say. So what happens, they all are getting attracted towards the positive plate. So this electron won't outrun and come here. No, what it does, it just gives a push to the next one, the next one pushes the next one. So like that, a drifting velocity every electron gets. Clear? Chalo. Got it, Soham? Yes, no, yes, no. Chalo, I'll again explain. Don't worry. I'll again explain later. Okay. Don't worry about that. Chalo. Let's finish it off. Again, we'll come back because what do you say? We don't get much of these kinds of questions, but still, we'll understand what drift is by showing you an example. Okay. Don't worry. Let's see this part. Electric field. So electric field we know that is equal to potential gradient, voltage by length. Okay. Now, first, whenever an electron is there in electric field, it will experience a force. What is that force formula? F is equal to QE. Correct. So here F is equal to minus E into E. Why a minus sign? Why a minus sign? The minus sign is to show what? Direction. Why a minus sign? Anybody can say? What is the electric field direction, student? Positive to negative. Yes, no, electric field direction, positive to negative. What is the force on the electron? Think about it. Chalo. The moment we get force, can we equate this is equal to ma? So from there, can we get the acceleration on the electron? Minus E by m. This will be using a lot of times. Clear? Now let's say correct. Correct, half moon. But why half moon? Why not full moon? Any particular reason for that? Now, so let's say a particle. How do we find the velocity of a particle, final velocity? V is equal to what? U plus AT. Let's say we are finding it for the first particle. So V is equal to U1 plus AT1. So for the drift velocity, so many particles are there. V1, V2 up to Vn. Okay. N number of electrons we have taken. So they're moving with n, what do you say, different velocity. So if I do a general, if I do the summation of or average of all of them, what I'll get? U1 plus AT1 plus U2 plus AT2 up to UN plus ATN by n. Now if you see initial velocity of all of them will be what? 0? Yes or no? Now because after the electric field is applied, then only they got drifted. Before that they were not in drift mode. So now after that what will happen? We'll get A into T1 plus T2 plus T3 dot up to Tn. Now what is this value? Can anybody tell? This T1, T2 up to Tn, why it is written as tau? Why it is written as tau or relaxation time? Anybody? Why it is written as tau or relaxation time? You have all given exam, physics exam, just simple. So basically in a cylinder like this or in a, what do you say, a jar you take or anything, so many electrons are there. They're just randomly moving here, there, here, there, here, there. The moment you apply electric field, the moment you apply electric field, what will happen? There'll be like what? Ordered movement. Clear? Now, what does this T1 plus T2 plus T3 up to Tn by n signifies? Anybody can explain what do you mean by relaxation time? Just kidding, bro. No, here you just kept account name half moon. That's why I just asked. Okay. No, I thought you watched any anime or something, and then by that you have written half moon. Because we have seen a lot of One Piece, Naruto, or something anime people are there. So I thought maybe some anime inspired this name is. Chalo. Anybody reason for relaxation time? Charge becomes 0. What is relaxation time? Anybody? Come on, anybody? You all have done your 12th. Okay, so time between two successive collisions. Okay. The time between start and end. I think he's scared of full moon, but that is not the answer for relaxation time, so average time period between two successive collisions. So relaxation time means the average time. What it does it means? The average time between two successive collision. Two successive collision. Okay. So you can write this part. What does tau means? The relaxation time means the time interval between which two electrons are again colliding properly. Correct. Chalo. So we got Vd is equal to A tau and we got Vd is equal to minus EE tau by m. From there we can we get the what is a formula? Vd is equal to, can we put the value of A? We got Vd is equal to A tau. A is equal to minus E capital E by m. Put tau. So will we get this formula? Yes or no? Vd is equal to minus EE tau by m. Everybody got it? Chalo. Next, current formula, I is equal to NEAVD, and I'm not going for the derivation part. If I'm taking volume is equal to AL, now I is equal to, we can go with this formula also, ANE square tau E by M. Both the formulas I need. Okay. This is very important. This is the third formula. Fourth, mark it down, write it down. Fifth, this we use very rare. So this, even if you don't remember, okay, but this, so what is say, 5 formulas, okay, very important. Do write it down, everybody. These 5 formulas are very important. Derivation again for the CET part or COMEDK part, you don't need as of now, and you just need to know how to apply in the question. You need to know how to apply in the question part, okay? So just do write down the formulas fast. And if you have written, do tell me. We'll move on to the next page. Will not go in the derivation part. Time is very less. Today is what? 26th is done. Correct. So 27th, we have very less time. We have to finish everything. Okay. Chalo. So we'll concentrate. Everybody has written 1 formula, 2 formula, 3 formula, 4 formula, 5 formula, the relation. Okay. 6, not that important. This is also important. Clear written, everybody? Chalo. Next, we'll understand in more details with the questions, okay? Don't worry. Next, mobility. Mobility, directly keep in mind, mobility is what? Drift velocity by electric field. Drift velocity by electric field. Directly say to yourself. Mobility means what? So, whatever the drift velocity they have divided by the electric field. So, Vd by E. That is equal to Q tau by M. Clear, everyone? Clear, everyone? Next, everybody written till here. This part written. Now, resistivity in terms of tau, M, N, and E square, very important. A lot of times they'll ask you, okay, how this resistivity depends on the, what do you say, number density of free electrons, inversely proportional. You increase this, this decreases. On relaxation time, you increase, this decreases. Clear? Clear, everyone? Now, one more thing, as this part is important. as we increase the temperature, the relaxation time, what happens? Decreases. Why? Because now electrons will be colliding much faster. Okay, the time between two successive, the moment you increase temperature means kinetic energy is increased. Now they are having more energy. So more energy means more faster collision. So tau decreases. So what happens? Rho increases. What happens? Rho increases. Got it, everybody? Very simple. Got it, everybody? Yes, no in the chat section fast. Come on, come on, come on, everybody. Come on, everybody. Very simple. See, the moment you increase temperature, what happens? The electrons have more kinetic energy. See, the moment you're more energetic, you fight more. Correct. So more faster you will fight. So tau will be what? The time between two successive collision will be or decreased. So if tau decreases, rho will increase. That's it. Clear, everyone? Clear, everyone? Good, good, good. Chalo. So what happens is rho is equal to this formula also we can remember. If they give you the what do you say this one temperature coefficient and the change in temperature initial we can find by this formula also. Just like resistivity we have done, resistance we have done, same thing resistivity also temperature dependence we have done. Clear everyone? Written, write down fast. To inform all your friends about the what do you say YouTube channel. Okay, that will be a very big help to us. Chalo, everybody got till here? Everybody written, got till here? Chalo, chalo. I'll move on to the next page. Will I go to the next page, students? Yes or no? Yes and no in the chat section. Chat is, I think, so loading a bit slower. It's loading slowly. समझ आ गया बच्चों आप सब लोगों को? चलो. Okay, chalo. Let's see the next page. Now this also is very important page. A lot of formulas are there here. Relation between J, sigma and E. Okay. We know J is equal to I by A, current density. V is equal to potential is equal to what? Electric field into length. And V is equal to I rho L by A, correct? So V is equal to IR, from there we got this. Okay. So we can write V is equal to EL and we can write I rho L by A. So L got cancelled. So E is equal to I by A is what? J only. I by A is what? J and rho. So if I do J is equal to what? E by rho. So E by rho, 1 by rho is nothing but sigma. So J is equal to sigma E. Very important. Clear? Very important, students. Okay. Either you can directly remember this formula or you can see the how we got it. We know current density is equal to what? Current by area. We all know this much. We know voltage potential difference equal to electric field into length. We know potential gradient part, that part we know. So done. So from here V is equal to what? V is equal to what? IR. So we know I can be written as what? I into R can be written as what? Rho L by A. Correct. So this value, okay, and this value can we equate? Yes, sir. EL is equal to I into rho L by A. So LL went home. So E, what do you say? What I got? What do you say? E is equal to I by A into rho. Now everybody knows I by A is nothing but J. So what we got? E is equal to J into rho. Now J is equal to what? E by rho. 1 by rho we know is what? Sigma. So E into sigma. So J is equal to E into sigma. Clear everyone? Yes or no? Yes or no? Clear everyone? Very simple, but is important. Very simple, but it's important. For your CT and COMEDK point of view, very, very, very important. Anybody, any doubt in any of the step? First line, see, every step is very important. J means current density. Keep in mind, what is current density? Anything by area. So current density means current by area. Done. We know electric field is equal to potential gradient V by L, potential by length. So V is equal to what? E into L. V is equal to what? E into L. Done. And V is equal to what? IR. So in place of R, I can write rho L by A. Done. Now equate this V and this V. Will get E is equal to what is say I by A into rho. I by A is nothing but J into rho. So J is equal to E by rho. 1 by rho is nothing but sigma. So J is equal to sigma E. Come on, anybody now doubt? Tell me fast. Anybody has a doubt? Tell me fast. We'll go on to the next page. We'll go on to the next page, students. Shall everybody got it clear? Good, good, good. Chalo, let's see. Next, we all know this is like from class 10th, we have done series and parallel combination. Series and parallel combination. In series, what happens? Voltage divides. Here, whatever the voltage, here, whatever the voltage, voltage divides. In parallel, current divides. One current, two current. Clear? So also known as voltage divider. And this is known as current divider. Very simple. Okay. In series, see, if wire is same, I'm going the same wire, current will be same. The whole area current same. Here what happens, the moment current hears, the moment current comes here, at this point he knows, oh, this R1 is good friend of mine, or R2 is not that good. So what will happen, it has more tendency, out of 10 times, 8 times it will go through this R1's house, and 2 times it's like, okay, I have to go, this is also like long time friend, so okay, done. So just based on current follows the path of least resistance. So if R1 is smaller resistance, it will go more from here. If R2 is what is a smaller, it will go more from here. That's it. Clear till here. Clear till here. Everybody, chalo. And here, this total voltage of the battery, V is divided into two parts. V1 and V2 equal or not depends on the resistance. Now R is equal to what? In series R1 plus R2. Directly we know. So voltage drops in the ratio of the resistance. If I want how the voltage drops, it drops according to the ratio of the resistance. Means if I want to find V1 voltage is equal to R1 resistance divided by total resistance into V voltage. Clear everyone? Clear everyone? This one is a very helpful part. This one is important. Do mark it, okay? What does it says is, let's say I have this one as 5 ohm and this one has 10 ohm. So total is what? 15 ohm. Total R is what? 15 ohm. So if I do R1 by total R, I'll get 1/3. So voltage 1 is equal to 1/3 of voltage this one. So voltage 2 will be what? 10 by 15, correct, into V. So that is equal to 2 by 3 times. Clear? Clear everyone? So directly we can do it. Clear everyone? Yes and no, yes and no, do say it. Or didn't get also, that is also good. Something should be there. Clear, 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 everyone. Chalo. One more time with example. See, understand, Karthik. What happens is, let's say we have a voltage V here. How much voltage will be here and here depends on this resistance. Now, if the resistance, this one is, let's say 20, and the other one is 10. Okay. So this is double times. So how much potential it will take? V2 will be what? V2 will be what? Current is same. So V2 is equal to what? Simple, understand. V2 is equal to what? I into R. So since its resistance is more, so what will happen? Will the V2 value will be more? Yes or no, kid? Yes or no, kid? Tell me. See, the voltage drop across this, will it be more if the resistance is more? Yes or no? Again, see it. Again, I'll explain. Don't worry. Okay. Now, let's say, take an example. I'll just take an example. R1 is equal to 10. R2 is equal to 20. Total R is 30. Okay. We don't know about V1 and V2. So what I did is find out V1. V1 is equal to 10 by 20 plus this one 30 into V. So again V by 3, 1/3 part is going. And if I see about V2, 20 by 30 into V means 2/3 part is going double. So since it has more resistance, so more voltage drop is there. Okay, it has less resistance, so less voltage drop. Clear? In case of series, current is same. So V is equal to IR. So here V will be what? Directly proportional to R. More resistance, more voltage drop. Clear? Everybody, yes or no? Yes, no in the chat section. Come on, Karthika, did you get it? Karthika, did you get it? Soham, yes. Clear? Chalo, let's see about the parallel. So since the current is same, so can I write V1 by V2 is equal to R1 by R2? Clear? Means if R1 is more, V1 will be more. Very simple, nothing is there in that. Clear? Chalo. Yes, sir, clear. What about Karthike? Got it? No? Lucky, Rohan, Pavitra ma'am, Nishat, Samiksha ma'am, all everybody getting it? Yes, no, do keep saying yes, no, at least it looks good. Okay. Chalo. And for this one, when the next class will be there and all, do follow the community post. I'll be putting it up there. Now let's see, in the case of parallel connection, current is what? It gets divided. How much it will divide? It gets divided by the logic of it follows the path of least resistance. Okay. It follows the path of least resistance. Okay. So here current is equal to I1 plus I2, but voltage is same. So V is equal to what? V is equal to what? I by R. V is equal to what? IR. And here I is equal to what? V by R1 plus V by R2. And this is I is equal to what? V by R. So V cancel, we can get this. And we can get this formula also we have done in class 10th, correct? So here current distributes in the reciprocal ratio of the resistance. Current distributes in the reciprocal. That is simple only logic. If you have a very high resistor, high value resistor, current will go less. Current will go less. Clear? Because the total multiplication I into R has to be constant. So if you are increasing R, this has to decrease because V value same, no kids. V, the battery, whatever is connected, whatever it has here, whatever, same thing on top. So if somebody has less of resistance, so current will go more. If somebody has more of resistance, current will go less because the total value actually has to be equal. The voltage on upper circuit and lower circuit has to be equal. Correct? Yes, no, yes, no, didn't getting so. Whatever bouncer, do tell us. Got it, everybody? Got it, everybody? If not, do tell me, do tell me. Chalo, everybody got it? Half Moon, did you get pro? Samiksha ma'am, got it, got it. Okay. Gokul, are you getting it? What about others? Amaya, if you're there, are you getting Vidya, Lohit, Lucky, and everybody? If you are there, do tell me. Getting, not getting. We'll go for the next page. Good, good, good. Do tell it. It gives the teacher the confidence. Yeah, students are getting. At least I'm able to teach a bit. So that is a good feeling. Otherwise, you stand with a crowd and you're just telling nobody's able to understand anything. That is very, very depressing. Got it, got it, got it. Good, good. Chalo. Clear? Next, this formula I don't need to explain. If you want, just you can write it as a part if they're giving 3. Otherwise, you can normally also solve it. You can normally also will solve it. I'll show you how to do it normally also. So no need. If you want, you can write where I am from. India, ma'am. Chalo. Correct. Chalo, everybody. This one, if you want, you can write. Otherwise, you can skip also. Okay. Because in while doing the what is it questions, we'll be able to solve in much better ways also. Just sometimes people need like, sir, for 3-1 you have not given, others have given. I've just written it. Once or twice, students, sir. What about 3, sir? Can we give a shortcut? Yes. If you want, you can mug up. It's okay. Chill. No issues. Clear? Fast, fast, fast. Everybody do tell it. Next, Kirchhoff's law. Very, very, very important, students. One question. Both CT and COMEDK you can expect. Clear, everyone? One question you can easily expect from either in one way or the other. Plus, Kirchhoff helps you in what you say, Wheatstone and everywhere, everywhere. Clear, everyone? Yes, no, students, they're not any reply. Come on, everybody, reply fast. Now, Kirchhoff's law, 2 laws we have, KCL and his buddy KVL. Now, KCL, what does it says? Okay, it is also known as junction rule. Okay, favorite topic, that's good. It's also known as junction rule. So, what does junction rule means? The amount of current that is coming inside has to go outside. No, it can't vanish. Correct. Current is not a magician. No. So it came just like PC Sarkar or something like that, and it vanished and appeared suddenly here. Can it do like that? No. So what happens? Whatever the amount of current came, if 10 ampere came here, 20 came here, 30 has to go. 30 has to go. Nothing can be done. See, that's so pretty simple. But still, he said, he got the rule, and in his name, he got famous. So, most of the physics things, if you see, they are pretty much common sense. Pretty much common sense. Nothing here and there. Because the amount which of current came in, that only will go out. No. If you think like that, what else will happen? Clear? If somebody says the amount of water coming out from a water bottle, okay, is equal to the water contained in the bottle. Correct? No, same thing. If I fill half the bottle, I'll get half the water. What there is extra in that? What something, what is it, different is there? Same thing. But he said in such a way, people became happy. Good. Next, KVL. KVL also important. What does it says? Algebraic sum what do you say? Sum of what I've written. I only am not able to read. Now let's see. See, basically is delta V equal to 0. What does means delta V equal to 0? What do you mean by delta V equal to 0? The total voltage in a loop is, if I do the summation of the total voltage in a loop, it will be equal to 0. Now let's see how do we use it. Okay. Now students, for the sign convention, in different books you'll get same thing but different way written. Okay. See, if I write x plus 2 equal to 0, or if I write x equal to minus 2, is there any difference, students? Is there any difference? Tell me, everybody. Vidya ma'am, is there any difference? Shom sir. No difference. Okay, sure. Let's see. Now what, and so we have different methods of taking. We can take any way. Like in what's a lot of books, it will be if I am going in the direction of current and if I see a resistor. Okay. So our direction and the current direction, if it is same, our direction of going and the current direction, if it is same, then we take V is equal to minus IR. We take V is equal to minus IR. Now in other books, it will be IR also, but it will be same. If you solve, I'll show it both ways, we'll get the same answer. Clear? Do not get confused, students. Very important. Do not get confused. I'll show you, okay, so that you don't get confused. Next, if the current direction and my direction or ours direction which we are going is opposite, what will happen? Positive. What will happen? Plus IR. The voltage drop is plus IR. Clear? So do write it down, these two. After that, if I am hitting the negative small danda of this battery, if the direction in which I am going, I am hitting the small danda of the battery, I'll take positive voltage. And if I am hitting the big danda of the battery, I'll take the negative of the voltage. Clear this part till here, everybody. Clear this part till here, everybody. Yes, no, yes, no. Fast, everyone. Come on, everybody. Come on, everybody. Yes, no, yes, no. Kartike, yes. What about others? Till here, everybody got it. Pavitra ma'am, Half Moon, Suham, Samiksha ma'am, Lohit, Nishat, Vidya ma'am. Everybody got it? Yes, no, yes, no. Keshav, good. Chalo. Everybody got it? No doubt in that. Let's apply it and understand it more clearly. Okay. Let's apply it. We'll understand how things are working. Okay. I'll show in both ways also. Chalo, let's see. Nobody is feeling hungry, no? Don't lie it, huh? How many people are feeling hungry? Now let's see. I'll just erase it. Now I've already made a circuit here. I want you to travel from point A, okay, of your journey. You start your journey from A, go to B, okay, be an adventurer, go to C then, and go to D, and come back to A again. Coffee ready hai sir. Oh, that's good. That's good. So whoever likes to have coffee, take coffee. For people who prefer milk, go with milk. Anything related to OH, just avoid it. Else, all okay. Clear up? Chalo. Clear everyone? Chalo. A, B, C, D. How will we do? So we are starting from A. Okay. We are starting from A. So what will be the way? What will we do? A to B, we are going in the current direction. What we have written? A to B, we are going in the current direction. So same direction, current direction, and our direction is same. So it is minus IR. So write down minus 4I1. Everybody got this? Minus 4I1. Done. After that, come to B. From B, I am hitting what? The negative danda. I am hitting the negative danda. What I said, if you hit the negative danda plus V, plus voltage, plus 4, plus 4. Then from C, I am again going in the current direction and getting a resistor of 2 ohm. So minus 2I, 1. And again I am hitting a negative danda. Again I am hitting a negative danda. Minus 2 volt. No, sorry, plus 2 volt. Correct. That is equal to 0. That is equal to 0. Clear everyone? Clear everyone? This part clear. We'll take, once we are done with this, we'll take a short break. Clear everyone? Yes, no, yes, no. Class will end it like after this we'll end the class. No issues. Fast, fast, fast. Chalo. We'll do the kidding later. Let's see. Everybody got this part. Everybody got this till this part. Now what if we are taking opposite? So if you just send these values that side, if I send it that side, what will happen? 4I1 minus 4 plus 2I1 minus 2 equal to 0. See, the whole sign convention I could have taken opposite. If I'm going in the current direction, I can take positive. If I'm going in the opposite direction, I'll take negative. If I'm hitting a big danda, I'll take positive. If I'm hitting a negative danda, I'll take negative. See, same thing. So no difference, students. Don't get confused. But yeah, follow one. Follow one. Clear. Don't follow half of this, half of that. Okay. That will end up in creating a blunder. Okay. Don't follow half and half. Clear everyone? Clear everyone? Don't follow half and half. Got it? So this part you write it and show me. I'm traveling from C. We can say you're going from Chennai to France. Okay. In between Bombay is there and Europe is there. Let's see. And back to Chennai. Let's see. Clear, clear, clear. Shall everybody clear? I need the answer for this, the second part. You're going traveling from Chennai to Mumbai to Europe to France and coming back to Chennai. So let's see what will be the answer. V voltage, bro. 4-volt battery. V value is just, oh, I haven't given this V value, no? Write down 2V. Done. Given 2 volt. Samiksha ma'am gave the answer. What about others? What about others? No answers from Divya ma'am, Kartikesh, Shuham. Fast, fast, fast. Pavitra ma'am. I3. Kartike kid started solving. Not bad, not bad. I3 equal to -1. -2i, 2v plus 4i minus 4v. What about others? Others. Chalo. Nobody wrote others. 10 people are here. At least 1, 2 more replies. Okay. So next we'll be discussing about Wheatstone Bridge in the next class. Tomorrow morning we might have Wheatstone Bridge, some other formats. Okay. Difference between EMF and what is it? Potential difference. Cells in series, parallel, meter bridge, potentiometer, and then that's it, done. So this chapter is almost done. After that, PYQs will be solving for CT and COMEDK both. Okay. So till here we'll keep it, students. Okay. Work hard, be good, and be dedicated. Be serious for these 15 to 20 days, whatever you have. These 15 to 20 days. Can you explain why is it plus 4i? Evening same for the YouTube part. Evening same time around 8:30. I will be there. Okay. Plus 4i. Which one? What do you say? Half moon. Which one you want me to explain? This one. This part how I wrote. Tomorrow time 8:30 around. Okay, between 8 to 8:30 the what do you say session will start. And for the PYQs, please do download the app Samclasses. Okay, you'll get the PYQs chapter wise. Okay, from there you can solve it. Answer given by Soham. Okay, in that answer given by Soham, let's analyze. See, he started walking from C. So when you go to C, I told you can go both ways. He took what? Positive danda as positive 4. Okay. No, he wrote minus 4. No. Yeah. So we can do, see here, what I told. If I am hitting the positive danda, it is what? Minus V. Clear. So if I am following this, positive danda equal to minus V. So when I hit the positive danda here, this is the big danda, no? So minus 4V. Then what I happened? Now I'm going in the direction of current I3. So same direction of current, so negative minus 2I3. Then I'm going in the direction of the current and hitting again a positive danda. So positive danda means minus 2V. And then I'm coming in the direction of I3. So it will be minus 4I3 and that is equal to 0. Clear? Clear? Yes and no, yes and no, half moon. The answer given by Soham. Soham, what did you give answer, bro? You gave minus 2I. I3 and all you didn't write. So minus 2I3. Then you gave 2 volt plus 2V. Okay, okay, you did a mistake. Plus 2V and minus 4V. Okay, Swam, see here, you have done a mistake. See here, bro, Swam. See, I got it, I got it. He has done a mistake. See, if I'm going and hitting the positive part, again, I told you earlier, don't mix it. See, if you have taken positive danda as minus voltage, okay, then same current direction means minus IR. Clear? Don't change it. Okay. So if I've taken positive danda as minus voltage, so minus 4V, I'm going here in the current direction. So what will be? Minus 2I3. Then again positive danda, so minus 2V. Again in the direction of current, so minus 4I3. That is equal to 0. Clear? Clear, half moon? Yeah, it should be minus. Clear? Yes, no, public, clear? Come on, fast. Do write in the chat section, fast, fast, fast. Got it, Soam? Is he there? Yeah, good, good. Doesn't matter with right or wrong. What the main target is, you came here to learn. You understood the mistake, done. Keep it in mind, not to repeat in the exam. Okay, till then, damn good. Anything else? We'll keep it till here, students. Chalo. So work hard, revise it once. If you have any doubt, do ask in the tomorrow session. Till then, see you off for today. Okay, chalo. Thank you all. Chalo. Anything else anybody wants to ask? Any doubt? Anything else? Anything? Anything? Got it, everybody? Chalo, chalo. We'll keep it till here.